Hi guys, welcome to Learning Electronics Repair. Did you guys see the video with this and its brethren, the green PCB version, which is very similar, that I published the other day? This is the one that was doing something inexplicable. And at the weekend, I decided to try to reproduce this on the live stream to see if anybody had any real idea of what was going on. And for whatever reason, on the live stream, it wouldn't do it. Yeah, it was not behaving. Obviously, it was on video. Yeah, you didn't notice the first time because it was on video the first time also. But it wouldn't do it. So I'm just going to show you what was happening with this. I'll link the video so you can see. But basically, I was trying to test an opto-isolator or opto-coupler. And here is the actual video. So let's just have a quick look at what I was doing. I have these needles in here, by the way, for testing Christmas lights, basically. So what do we have? This on here, you see 1.05. Notice that the transistor, that's on the black multimeter, this one here, was reading 4.3, and when I touch it, it goes down to 3.0. And this is my backlight tester. So it's set to 1 milliamp. This will provide 1 milliamp to the LED in the opto-isolator. And I'm doing this because my other multimeter, I'm not using it now, is not capable of doing that in circuit, okay? In diode mode. It will with some opto-isolators, depending on the surrounding circuit, but not this one. 1.0, so it's 1.0 volts, yeah? If we watch the meter here now. Yeah, 4.16. Now watch. It changes, yeah. And it's gone a bit crazy. It's switched on down to 1 ohm, basically. And look, I take the black lead off. Okay. So at this point, I now have 21.8 volts on the backlight tester because it's open circuit, and yet the transistor is still acting like crazy in the opto-isolator. Look. Go back down again now. How can it do that? Because there's no current into the LED. Take it back off, it settles down. Now, that's enough to actually get that to respond. Yep. So I've only applied the red lead, the black lead is not applied. This PCB, the Aircon controller PCB, is not connected to the power or anything else. And you'll see on here, this is saying 22.0 volts. So there's no current passing through the LED, otherwise that would drop to 1, being a constant current source, okay? But it's connected to it. Yeah, look. Interesting. What strange circuit is this? I mean, I'm now connecting one end, so the LED shouldn't light, look. It's switched on. Okay, so that's the inexplicable thing I was demonstrating. Later in this video, I actually show the reverse engineered schematic. Not all of it, but this is where I'm injecting the current to light the LED, and this is the transistor I'm measuring across. It's an opto-isolator. This circuit, this part is on the high voltage side, and this is all on the low voltage side. So it shouldn't be able to pass any current this way. In fact, it's not doing. The backlight tester says 22 volts. That means there's no current flowing out of it. Yeah. And yet it was still affecting the multimeter. That was what I found. Now let's try this again today. Okay, so I have these clips on the opto-isolator connected to the multimeter. This is the same as before. There's the multimeter, 4.158, the same as before. Here is the backlight tester, 22.1. And if I short the leads on the backlight tester, it just goes to 0. Because it's a constant current source. Let's try what we did before. So, red lead onto the anode of the LED and the opto-isolator, which is here. Black lead onto the cathode. To my right hand now, you see the backlight tester is saying 1 volt. that's the voltage drop off the infrared LED at 1 milliamp, and the meter reads 3.7, and then it goes back to 4.15. And just connecting the red lead makes no difference at all. That's how it should behave. Again, like the LED. Yeah. 1 volt on the backlight tester, 3.7k. So you can see I'm turning the transistor and the opto-isolator on. It's possible that the opto-isolator isn't good, so the LED emission is low and it's not turning on as much as it should, but it's basically functioning. And we can try that on the other PCB. So this is the one that I previously checked everything really. I can't find anything wrong with. The blue one I haven't checked, so let's do the same on the blue one, see if we get the same readings. Let's check on that one for obvious things, make sure the standby supply is working, make sure that everything looks okay. And then what I want to do, if they both look okay, is I want to look at this EEPROM. So this, according to information on the internet, on Tinternet, as they would say in Yorkshire, although I'm not from there, this EEPROM, if it fails, causes a communication error, error F4 or similar, depending on the make of the board, okay? And what I wanted to know, and I still want to know, is whether this EEPROM contains firmware, or whether it just contains the user settings, and if the user settings are corrupted, then we get a communication error. That's what it suggests looking around on the internet, but not giving that much information. It also suggests there's a pull-up resistor here on the chip select, and that there's a resistor between the microcontroller and the EEPROM as well, and if that's failed, obviously it can't be the EEPROM. So that's the thing I want to investigate today. How I propose to do this is to take the EEPROMs off both boards and read them, store the information using my EEPROM programmer, see if I can program them to see if the EEPROM actually works. Will it take a program and verify, and that way determine whether the EEPROMs are actually faulty. And maybe we can figure out whether the contents are in fact program instructions firmware or just user data. Okay, this is the other PCB, the blue one. The opto-isolator here is in a different physical position, but this is the unisolated or high voltage side of the PCB. This is where the mains comes in, just here. You can see this is where we have the 2K resistor, the 330 ohm resistors, 2 in series, the high voltage capacitor, the diodes. These are the ones that were drawn on that rough schematic I made. And this is the opto-isolator with the LED in this part of the circuit. The other one's the other way around on both boards. So this one takes communication from the indoor unit to the outdoor unit, so coming in this way. And this one is sending information back. You can see a big slot in the PCB here, Luke. This is the junction between the high and low voltage side of the circuit, okay? If we look on this one, this reads 4.89k, so a little bit higher than the other one does. But they both supposedly have the same fault, although I say the same symptoms, the faults could be different. So we'll just connect onto here. Oh, Luke. For a moment it went a bit crazy. Let's get the backlight tester where you can see the readout. I know it's a bit difficult for you guys to read. It does say 22.2. Let's light the LED. This has gone to 1 and that's gone to 2.7. So this has a slightly larger reaction than the other one, but similar. And just touching that with the backlight tester doesn't do anything crazy on this one either. So I really don't know what was going on previously. I can't reproduce it, so let's just ignore it, I think. Okay, so I'm going to power this board up. We're going to see if we have 5 volts and 12 volts on this one. Hopefully we'll see some LEDs on and hear some relays click. And If it's doing the same as the other one, then let's have a look at these EEPROMs. Here we are. We can see the light bulb there, so that's switched into circuit. Let's switch this on and see what it does. Bright and then dim. So it's drawing some power. You saw the LED flashing. I hear the relay. So I'll just wait till that drains the capacitors. We'll power this up without the light bulb. Okay, go. So this does what the other one does. The red LED flashes and we hear a relay go click. So they both do the same thing. Another thing I tested on the other one was whether or not the PFC is running. And it wasn't running, but I did surmise that may well be normal, because until the motor's running and there's any load, the PFC may not be activated. It probably doesn't need it when it's effectively in standby, can we say? It's not driving anything. So let's have a look. To do this, we measure across the main capacitors, which have a little bit of voltage in, Luke. You can just see there. Let's power this up. And this has 312. So that's basically the same as the other board. The PFC isn't running, because both boards behave in basically the same way. I'm not going to check all the components on this one like I did on the other one. I'm going to have a look at these EEPROMs. So I think this is EEPROM chip. I'll just clean it off. And then I'd like to check the contents of the EEPROM. The other thing I'd like to know is, does the microcontroller have its own flash memory? If it contains memory, then by sort of a sensible deduction, the program, the firmware, is in the controller. Okay, let's have a look. This then is the microcontroller on the blue PCB, R5F562. Some of the letters. Okay. Can't quite read that digit, but maybe a 1, yeah. But R5F562 1, I think. Okay. The other one, RX24T8 F524. So different, okay. They are different. This one on the green PCB has a 24C16. So that is a 16 kilobit EEPROM arranged as 8-bit bytes. So that is a 2 kilobyte EEPROM, okay? This doesn't look like an EEPROM, not that number at least. Not one that I would recognize as an EEPROM. It's not on the back of the board, but it does have, look, there's like a quad resistor pack there. 100 ohm, another one. This is IC301. I'm just looking around here to see what we have. This has banks of resistors, so not the same. So there's similar area. This is IC203. Whether the numbering system matches in any way, really don't know. There's obviously different manufacturers of similar boards, or two similar boards from the same manufacturer. Let's see if we can make anything of that number at all. 24C16, as I said, this is I2C, buzz, EEPROM, 2 kilobytes, 16 kilobits, okay. We can see there, VCC, SDA, SCL, this is how it communicates. It has active low, WC, which is not a toilet. Yeah, right control. Right protect. I don't see a chip select, but it probably comes through this, I'd imagine. But that is the EEPROM on one of them. The other one, this T167177 or T16, I can't find anything for this one. I suspect it's another 16 kilobit, 2 kilobyte EEPROM, but I don't know. I could try just reading it as a 24C16 and see what happens. Okay. This is the processor on one of the boards, the one with the least pins. So we can see this is 80 megahertz, 32 bits, MCU, 80 megahertz pulse width modulation, 3-phase complementary output. It did mention somewhere in here, I can't just find it now, that this is suited for motor control drones, for example. So this is a powerful CPU, or MCU rather, microcontroller unit. It has on-chip code flash memory. Yeah, 128 kilobytes up to 512 kilobytes. Much larger than the EEPROM, which is 2 kilobytes. So I really don't see that EEPROM contains the code for this microcontroller. Okay, it is much more likely to be user settings. The other one, although I can find R5F562 on all datasheet, for example, it's the same manufacturer, Renesas. Okay, Renesas. When I go to the datasheet, which says it is the datasheet, and click on it, it takes me to RX62 and 621 group. So I can assume it's part of this same group. This is a very similar sort of microcontroller. I'm not totally sure this is the correct datasheet. But again, I suspect it's a high-powered microcontroller, 32-bit with lots of RAM. Okay, so let's take the EEPROM off the one which we can read. I'll take the other one off as well and see if I can read it or not. And let's have a look to see what's inside that EEPROM, if we can actually see anything other than a load of hex. Okay. Okay, let's see if we can read our chip. I've selected the one which is closest to the one I have. It's ST. Well, mine says 24C16R, and there's another letter, but that's close. Okay, so we go with that one. Let's see if we can read this. Read. Oh, and we did. Very, very fast. Okay. This is actually the newer version of the program, and the one I've been using before was the TL866A. This is actually a TL8662 Plus. Okay, so this is a newer version. Maybe that's why it's much faster. So that's the contents of our EEPROM. There's certainly some, well, I think it's kind of like plain text in here. Yeah, looks like it is some sort of text and various other information. That looks, for example, like some sort of serial number. Yeah. Okay, so that's what's actually inside the EEPROM. I'll save that. It's already generating part of a file name for us, which is the device and package type. So I'm just going to add to this Aircon. One, why not? No, let's call this one Aircon Green, because that's the PCB it came from. Okay, save. So that's what's inside this EEPROM. Let's have a look to see if we can read the one from the blue PCB as well. To do this, I've just unsoldered one of the capacitors from here because I couldn't get in with the hot tweezers from either direction, really. And they seem to do a pretty good job of this, actually. Let's add a bit of flux and see if we can get rid of this glue by adding some solder. Hopefully this will just melt the glue, basically. We'll see. Yeah, it looks like it's got rid of that. Okay, fine, it's bridged. If anything, that will help. This is difficult actually because the heatsink is in the way of my hand as well. Everything's making this more difficult. Let's see if I can get in this way. coming a bit loose, not easy. I'm really not at a good angle here, guys, but I think I'm going to have it. Okay, I'm finding those hot tweezers just amazing. I mean, previously I would have to do this with hot air, with all the risk of damaging or losing nearby components, or damaging the PCB. I'd probably have to unsolder the other capacitors to stop them overheating and maybe even exploding. So that thing is saving me a lot of time. How on earth did I ever manage without that? Yeah. And we're ready. I don't know if we will read this because I don't know the type. It's nothing I recognised. But I'm thinking if these processors are the same family, or at least the same make, very similar, that the two EEPROMs are probably the same capacity, because you probably basically have the same firmware in these things, and it may well just work. So I'm going to try this. Let's just see if we can actually read this chip on the same settings. Okay, so let's have a go. And in fact I did. Do the contents look similar? Yeah, they do. So I would say this is the equivalent of the other chip. Could be replaced by the other chip. That's the thing, it looks like a serial number again, like you see. So that's how to read these in an attempt to prove whether or not this contains any sort of firmware or settings that the board needs to boot up. I'm going to erase the chip. I've copied the contents to my PC, so it's not really a problem to restore it. I'm going to blank this and then we'll put it back on the board and see if the board still does the same thing. So if we still hear relays click and we see the red flashing LED, we can to some extent say maybe doing the same thing, but the honest truth is we're going to have to put this back on the Aircon to see whether it now works. Anyway, it's interesting, don't you think? So let's erase this, let's refit it and let's see what happens. Once again then I will read the chip. There we go. I won't save it this time because we already have this saved. I will actually blank it. So blank, blank. Check blank flash failed. So it's saying pins detected pass, so it's detected not empty. Oh, interesting. I'm going to load the file from the blue PCB. That one. Okay, we have that file. Let's try to write this file to the EEPROM. Okay. Yeah, so I've written that to it. So the chip actually works. Okay. That's the file from the other PCB. I'll try again to actually blank this. Blank. Well, I seem unable to blank it. Let's try filling this with, yes. Okay, so I've filled it with all F's. And we'll write that. Okay. Well, that's done. It's now full of FF, so there's definitely no data in there. I must admit, I've never tried to use the blank option before. Maybe it doesn't work in the way I thought it would do. Never mind, we now have an erased EEPROM. Let's put this back onto the green PCB and see what it does. And there it is, soldered. What do you think will happen? Only one way to find out, yeah? Okay, let's do it. Let's see. Well, it doesn't do anything. Oh, and then it started. I didn't leave it long enough. Maybe, do you notice it took longer before it powered up? I wonder if it's rewriting the firmware as it boots up. It definitely took longer. Interesting. I think, and I hope you agree with me, it may have done something. Yeah. Relays are clicking away. Notice I've turned the power off, by the way. It's just kind of like powering down. Yeah. That was quite interesting because this was behaving differently once I erased or put all F's into the contents of the EEPROM. It took longer to boot up, and then there was more relays clicking than previously. So I've unsoldered the chip again. I'm going to put this back into the reader and see whether it still contains all F's or whether something else has happened. Let's find out. Well, it's still all F, so the microcontroller hasn't rewritten data back to this. It's just all F's, yeah. Whether that is because we need to effectively connect it to the indoor unit and, you know, start the thing with a remote, and then maybe it will record some data. I don't know, but I think because it behaves differently, I'm interested now in sending this back to the guy, can connect it all back together again, and let's see if it works or it behaves in any different way regards the error codes. I can only send one back because the other one, the blue one, the owners of that one are not on the island again. They sort of come and go sporadically. But I'll get in touch with the other guy. He is the guy who, you know, effectively disconnected the thing. I'll give him the board back, say go reconnect it, and we'll find out. Okay, so I'll come back to you guys on this one. But in the meantime, yeah, get down there. Let's talk about it. Any thoughts about that? Any ideas about that? Or maybe just like me, it's interesting. Okay, hope you enjoyed that, and I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.